Determine the color codes for each of the following resistors resistance. We have Roman 1, we have this value, or this. So we are going to write either for this or this. Then we have Roman 2, we have this and the or this. So in the first one, from the given values, if you observe them very carefully, in this value we have a plus 5, and when we have this we have a minus 5. So it means the resistance here is the actual resistance here is 75 billion, like that. Then we have a plus or a minus 5. So we have a plus or a minus 5 at the end, if we consider for the second value. When we come here again, you'll notice that the resistance here is a 34 million, and we consider a minus and a plus 20, because for this we have a plus 20, for this we have a minus 20 when we consider that 4 million. And also when we consider this, for this it is a minus 5, and here we have a plus 5. So first of all, before we go to how we determine these resistances, so before we go there, let me mention something else. The way these resistances have been given, it means that the plus or the plus and minus, the value at the end, will represent the tolerance. So the first case, the tolerance is plus or minus 5%, and in the second one, the tolerance is a plus or a minus 20%. So that is how these values have been framed, which is very tricky if you don't observe them at that angle. So when you are doing color coding, you can always master this table. These are the colors that are used. So I will have the color, I love the significant digits, I will have the multiplier, and I will have the tolerance. So these are the colors. We start from the first one, gold. We have black. We have brown. We have red. We have orange. We have yellow. We have green. We have blue. We have violet. We have gray. We have gray. We have white. And then we have none, whereby we don't have any color there. So for the gold, we don't have significant figure here. We don't have also for the for this, the first one, the very first one is silver. The first one is silver. We go to gold, we go to black, brown, red, orange, like that. So for the silver and gold, we don't have any digits. For the black, we start with the digit 0. So for this one, we start with digit 0. The next one, then we write the others following one another up to 9 for white. 5, we have 6, we have 7, we have 8, and for white 9. Then for the multipliers, silver, it is power negative 2, that is 10 power negative 2, and gold, gold is power negative 1. Then multiplier for the black is 1. For brown, we get 10, which is 10 power 1 now. We go to 10 power 2. The reason why we are putting for black 1 is because it is 10 power 0, which is 1. Any number power 0 is 1. So we go for brown 10. This is now the same as 10 power 1. And we will go from there, increasing the powers by 1 up to white, which is power 9. So this is power 3, power 4, power 5. This is power 6, power 7, power 8, and power 9 for white. When you go to the tolerance, the first one is a plus or minus 10%. The second one is a plus or minus 5%. We don't have anything for the black. Then we have for the brown is a plus or minus 1%. The next one plus or minus 2%. We don't have for orange and yellow. Then after that, for the green, we have plus minus 0.5%. Next is a plus or minus 0.25%. The next one is a plus or minus 0.1%. Then we don't have for gray and white. But for none, we only have the tolerance of plus or minus 20%. So with that table, now we can compute our color coding for the question. So in this case, Roman 1, let's change the value. I have said the actual resistance here, when you look at how the values have been framed, the actual resistance is 7.5, that is 75 billion. Then we have a plus or a minus 5 tolerance. So in this case, we have to change it to power form or in scientific form. Let's change it to power form. So when you consider 7, 5, 9 zeros, and we change to power form, you'll find that we have a 75. So don't put a decimal point in between 7 and 5, because we work with the digits, full digits. So 75 times these zeros will form a 10 power 9. Then this resistance add a plus or minus 5%. So now you take this power form to the table. So the first digit, we have first digit, second digit times a 10 power 5 plus minus 5%. So in this case, you look at 7 represents what in the significant column digits. 7 represents violet. So 7 will represent violet. You go to 5. 5 represents green. 5 represents green. So we have 5 for green. After that, now the next thing is the multiplier. We don't have any other digit. The next is a multiplier. Multiplier of 9, power 9 is white. So this will be white. And a plus of or minus of 5% is of gold. So gold is the one that has a plus or minus 5%. So this is gold. So it means this resistance is a 4-band resistor of the color violet. This is how you write it: green, white, and gold. So the first one answer is that. Let's go to the second one, whereby we have said it is that 4 million and a plus or minus 20%. In power form, this is that 4 times 10 power 6 and a plus or minus 20%. So you read the first digit. First digit represents 3 and the 3 is orange. So the first one is orange. Second one is 4 and the 4 is yellow. So we have yellow. The third one is a multiplier of 6 and multiplier of 6 is blue. And we have the fourth component to read is the tolerance of 20 plus or minus. And in this case, we find that for the 20% tolerance, we don't have any color. So we don't write any color there. So here we don't have any color. So the resistance will, the color code now will be orange, yellow, and blue. So that is how you write it, because the fourth band has no color. So to finish up, let me remind you something about resistor color coding, whereby if you are given for example a 5-band resistor, if you are given a 5-band resistor, let's say this is the resistor, then we have first band, second band, third band, fourth band, and fifth band. You start from left. So from left, what you have to know that in any band resistor, be it 4, be it 5, be it 3, the last two bands represent multiplier and tolerance. So the very last one is tolerance, the second last is multiplier. Then the rest, if it were 5-band, will be digits. So it means you read the colors of the digits represented under the column of significant figures or significant digits. So it means these 3 will be digits. Then we go to multiplier and we go to tolerance. If it is a 4-band, we we have the very last two representing multiplier and tolerance, and the rest, which are the two, will represent digits, will be digits. And that is what has happened here. This is a 4-band resistor whereby we have two digits, multiplier and a tolerance. Also in the first Roman, this was a 4-band which represented digits, two digits, a multiplier and a tolerance. We don't have 5-band or 3-band.